Hello friends, welcome to engineering tutorial. So in this video we are going to continue with our discussion related to some basic important parameters associated with motion. So we are going to discuss about another important concept related to the parameter which we've already discussed, which is velocity, which is the concept of relative velocity. So before we discuss this, let us just visualize a situation. Okay, so let us say we have a car. Okay, this is the road. We have a car, okay, a van or a car, whatever it is. It is moving in this direction. Okay, and here we have a tree, let's say. Okay, here we have a tree. Now if you have visualized this situation when when you are not driving, okay, when you are not driving and you are someone else is driving and you are just looking outside the vehicle, it can be a car or it can be a train or bus, whatever. You're looking outside the window and you watch the nearby trees passing by, so if you just just relax and concentrate at that moment and visualize as if the bus is stationary. Okay, the bus, it's actually the bus or the car, the vehicle which is moving towards the tree. Okay, it is moving towards the tree, but to the person who is sitting inside the vehicle looking outside of the window, it appears as if the tree is moving towards the vehicle. Okay, this is the illusion that is created. So if the person sitting inside the vehicle just focuses on that particular moment, imagining the vehicle to be stationary, it appears, okay, it appears as if the tree is moving towards the vehicle, but in reality it is the vehicle which is moving towards the tree, and then it crosses the tree, and then when the person looks behind, okay, it appears as if the tree is moving away from it. So when it is approaching the tree, it appears as if the tree is moving towards it. When he crosses the tree, it appears as if the tree is moving away. So this is the concept of relative velocity. Okay, so if you remember, we discussed in the introductory concepts about absolute rest, relative rest, absolute motion and relative motion. And we also said that the concept of absolute rest and absolute motion, they are impossible to achieve. They are theoretical concepts which are not practically possible. So absolute rest is the case when both the object under study and the frame of reference, they are both at rest. We cannot have a frame of reference on earth which will be at absolute rest, because the earth itself is moving. It is moving around the sun, it is rotating about its axis. That is not possible. Absolute motion is the case when the object is moving but the frame of reference is still, it is at rest. Again, it is not possible because the frame of reference for our measurements which we consider as earth, it is impossible to achieve for a absolute rest thing. So here, for our just to make things simple, we will say that this point here, the tree, here it is located on earth. Let us just set aside the concept that the earth is moving, and we just say that this tree here, it is still, it is at rest, it is not moving. Let us not bring the movement of earth into play here. Just because we are located on earth, we will say that this is at rest. The velocity of tree is equal to 0 meter per second or kilometer per hour, whatever. This is 0 meter per second. The vehicle, the velocity of the vehicle here is, let's say, whatever, let's pick any value, let's say 5 meter per second, okay, just for the sake of discussion here. We say this is the velocity of the vehicle. It is approaching the tree. So here relative velocity is expressed as relative velocity of one object with respect to another. It is expressed as velocity. Let's say there are two objects. This is object 1, this is object 2. Relative velocity is expressed as velocity of object 1 with respect to object 2. It is written as this. When you see relative velocity expressed as v subscript 1, 2 or anything, it can also be written as v subscript ab also. So it is velocity of object A with respect to object B, and it is expressed as velocity of object 1 minus velocity of object 2. Here it is velocity of object A minus velocity of object B, like this. Okay. So here if we say for this, the velocity, the relative velocity of the vehicle with respect to tree, it will be velocity of vehicle minus velocity of tree. It will be 5 meter per second minus 0 meter per second, because velocity of tree is 0 meter per second. It will be 5 meter per second. Okay, this is the velocity, relative velocity of the vehicle with respect to the tree. So it means tree here is the reference. The second part of the subscript is the reference point. This is the reference point. So if someone is sitting on the tree, for him it will appear as if the vehicle is moving towards it as a velocity of 5 meter per second. Another interesting thing, let us say we calculate the relative velocity of the tree with respect to the vehicle. The relative velocity, this is a very interesting concept which I was talking about, the illusion part. Velocity of the tree with respect to the vehicle. So suppose we say that we have someone, okay, in the vehicle. Okay, we have someone on the vehicle, and this is the tree here. Okay, so here if someone sitting inside the vehicle visualizes that the vehicle is stationary, the illusion that is created is that the tree is moving towards it at a certain velocity. This is that part, velocity of tree minus velocity of the vehicle. So here it will be velocity of the tree is 0 meter per second, velocity of the vehicle is 5 meter per second. This will be minus 5 meter per second. Okay, so it means for someone with respect to this vehicle as the reference, I always said the second part of this expression, the subscript in relative velocity, is taken as reference. The reference is considered to be visualized to be still, in still position or rest. So for a person who is sitting inside the vehicle, for him it appears as if the tree is moving towards it at a velocity of 5 meter per second. Here the negative sign comes into play because it appears as if the tree is moving towards it, towards left. towards y-axis. So this brings us to an important thing which I should have told you earlier. So for this discussion we will consider, as velocity is a vector, okay, velocity is a vector, we will use the Cartesian coordinate system x, y. So here every velocity vector or motion towards the right side will be considered positive. Towards the upward side, well, it will not be coming into play, but still normally when we take sign convention, anything upwards is considered positive. Okay, so any motion or velocity towards the right side vector, it will be considered as positive. Upwards, upward motion or upward velocity, which will not come into play here, but you just understand this, know this, because when we'll discuss other things related to gravity and all that will come into play. So here upward motion is considered positive. Similarly, to the left hand side, okay, from the origin towards the left hand side it is considered negative, and downward motion is also considered as negative. Okay, so towards the right, upwards, these are positive, towards the left and downward it is negative. So this is the same thing here. When we try to calculate the relative velocity of the tree, okay, the relative velocity of the tree with respect to the vehicle, then we visualize the vehicle as the reference as if it is still, like we have an illusion. If we sit inside the vehicle and see outside, it appears as if the tree, as nearby tree which is a little bit far ahead, it is approaching us, or the buildings, shops, whatever structures, buildings there are, it appears as if they are approaching us, and the vehicle is still and they are approaching us and they are passing by. So this illusion is because of relative velocity, and this relative velocity here is minus 5 meter per second, which is the negative sign. Magnitude is 5, sign is minus because it is as if it is moving towards the left. So here we'll consider different cases for relative velocity. Okay, so let us say we have a car. Okay, we have a car, and okay, so before that let us write the general expression of relative velocity with respect to this sign convention. So we know that relative velocity is expressed as this. Okay, let's say we consider two objects, 2 points A and B, and we are determining the relative velocity. So relative velocity of A with respect to B, 2 points A and B. Okay, they have certain velocities VA and VB. Direction is I have not specified here. It can be in any direction, towards right or left, towards right or left. Okay, so general expression I am writing VAB, that is velocity of A with respect to B, that is written as plus minus VA minus plus minus VB. Why plus minus? Because we don't know in which direction the point A is moving, whether towards the right or towards the left. If it is towards the right, then it will be plus. If it's towards the left, it will be minus. Similarly, VB, we don't know in which direction it is moving. If it is moving towards the right, it will be plus. If it is moving towards the left, it is minus. This minus sign will always be there. We subtract the reference point, the second, okay, the second point velocity of the second object, which is considered as the reference, from the velocity of the first object. This is the general formula of relative velocity. Similarly, VBA, that is velocity of B with respect to point A, that will be plus minus VB. Same reason, because we don't know in which direction point B is moving, minus we subtract the reference. Here in this case A is the reference. Okay, it is considered stationary. It is visualized as stationary. VB minus VA. Again plus minus VA because we don't know in which direction it is moving. Right, positive, left, negative, both the cases. So always remember the general formula of relative velocity. Always the second point is considered as reference. It is considered to be at rest in still position as if someone is sitting on it, and the velocity of A is visualized. Okay, always remember this. Always the second part is the reference. So here we will consider different cases to understand. Let us say we have a car A which is traveling in this direction towards the right, towards, let's say, a pole. Okay, a pole which is stationary. Okay, this is the pole. It is moving with velocity VA. As it is moving towards the right, it will be considered as plus VA. Pole is stationary. The velocity of pole is equal to 0 meter per second. So here the relative velocity of car A with respect to the pole is equal to plus VA minus V pole, the velocity of the pole which is stationary. No need to put any sign because it is stationary. Let's say the car is approaching with velocity 5 meter per second. So in this case it will be plus 5 meter per second minus 0 meter per second, which is plus 5 meter per second. The relative velocity of car A with respect to pole. Here this is the reference. So someone sitting on the pole, to him it appears as if the car is approaching the pole with a velocity of 5 meter per second. Towards the right, that's why plus. So another situation, velocity of the pole with respect to the car. Here this was the reference, now this will be the reference. So to someone sitting inside the car, it appears, okay, to someone sitting inside the car, it appears as if the pole is moving towards it, with the opposite velocity. So here we will calculate, it will be V pole, first thing will always be, it will come first, the velocity of that will come first from the relative velocity formula which we discussed. V of velocity of A with respect to B, VA minus VB, velocity of V with respect to A, VB minus VA. Sign is put as with respect to the direction in which they are moving. So here it is velocity of pole minus, okay, the velocity of the pole. So here the velocity of pole with respect to A, it will be V pole minus, it will be velocity of point A, it will be 0 meter per second minus plus 5 meter per second, because VA is positive towards the right. So it will be minus 5 meter per second. So in this case, it will appear to someone sitting inside the vehicle, it will appear as if the pole is approaching towards it with a velocity of 5 meter per second. So let us consider another situation so that we are crystal clear about this. So same case, we have a pole, stationary pole on the road, and we have a vehicle which is moving away from it. Okay, a vehicle which is moving away from it. So in this case it will be considered minus VA. Pole is stationary, it will be minus VA because it is moving towards the left. So in this case, the velocity of the object A with respect to the pole with pole as the reference, it will be VA, actually minus VA minus V pole. So let's say it is same, minus 5 meter per second. So it will be minus 5 meter per second minus 0 meter per second, because it is stationary, it will be minus 5 meter per second. So with respect to the pole as the reference, someone sitting on the pole, okay, for him it will appear as if the car is moving away with a velocity 5 meter per second, away from it towards the left. So this is for the left side movement, this is the magnitude, this is the direction. Similarly, let us consider another situation. Okay, velocity of A with respect to pole. Now velocity of the pole with respect to A. So in this case it will be V pole minus VA. So in this situation, what we are trying to do, we are considering A as the reference. So to someone who is sitting inside the car and assuming it that it is still, to that it will appear as if the pole is moving away, okay, moving away. For someone sitting inside the car, actually the car is moving, okay, away from the pole, but to someone who is sitting inside the vehicle, if he or she looks outside the window, to him or her it will appear as if the pole is moving away. So it will be, that velocity will be minus 5 meter per second, that will be plus 5 meter per second. So this is the relative velocity of pole with respect to A as the reference. This is the beauty of relative velocity. So these are the two cases where we have discussed one of the object is moving, another one is stationary. So let us consider other cases where okay, so let us consider other cases where we have two vehicles. Okay, we have two vehicles, A and another vehicle B. Okay, A and B. Both of them are moving towards the right side. It means both of the velocities are positive. That is plus VA, this is plus VB. So here, first, relative velocity of A with respect to B, with B as the reference. So here in this condition, what we have to do is we have to assume that a person is sitting on or inside vehicle B and visualizing as if vehicle B is stationary at rest. So to him or her it will appear as if the vehicle A is either moving towards it or away from it. It depends on the value of VA and VB. If VA is greater than VB, it will be something different. If VB is lesser than VA, it will be something different depending on the sign. So here it will be simply plus VA minus plus VB. So here if VA is greater than VB, it will be positive. Positive means it will appear as if it's moving towards it, towards the right. If VA is lesser than VB, okay, if VA is lesser than VB, it will be negative. It will be negative, okay. It will become negative and it will appear as if it is moving away. So these things are a little bit difficult to grasp in the beginning, but you have to visualize it, okay. That's why I gave the example of, this tree and man and all that. I gave this example so that you can get a feel of things. Similarly, velocity of V with respect to A, it will be, both of them are moving towards the right, so it will be positive sign, VB minus plus VA. So here it will be simply VA minus VB we can write. Here it will be VB minus VA. So here if VB is greater than VA, it will be positive, and if VB is lesser than VA, it will be negative. Here A is the reference. So in this condition, someone who is sitting inside vehicle A, assuming that it is stationary, that is the reference, to him or her, it will appear as if the vehicle V is moving away from it if VB is greater than VA, and if VB is lesser than VA and VA is more, it will appear as if this vehicle is approaching him because of the negative sign. So always remember, positive means moving away, negative means moving towards. Always remember these sign conventions. Okay, so here we have this case. Then same thing, if we have two vehicles moving in the same directions but in the opposite. Here it was moving towards right, here they are moving towards left. Same thing, A, B. Here both of them are negative. Minus VA, here it is minus VB. So VAB, with B as the reference, it will be minus VA minus VB, which will be minus VA plus VB, which is equal to VB minus VA. And velocity of B with respect to A, with here B is the reference, here A is the reference, it will be minus VB. Why? Because they are both negative as they are moving towards the left. Minus VB minus VA. So it will be minus VB plus VA, which is equal to VA minus VB. So here if VB is greater than VA, the result will be positive. If VB is lesser than VA, the result will be negative. Here if VA is greater than VB, the result will be positive. If VA is lesser than VB, it will be negative. The same thing, positive means, here positive means with B as the reference, it will appear as if A is moving towards it, and here when it is negative, it will appear as if A is moving away from it. Similarly, with here A as the reference, if it is positive, the relative velocity is positive, it means it will appear to someone sitting inside as B is moving towards it. If it is negative, it will appear as if it is moving away from it. Okay, but in reality both of them are moving. So these are the two cases. Then another two cases where the two vehicles are moving in opposite directions. This is moving, let's say, towards, and this is also moving towards it, towards right, this is towards left. This is A, this is B. So here as it is moving towards right, it will be positive, that is plus VA. This is moving towards left, this will be negative, it will be minus VB. So here relative velocity of A with respect to B, with B as the reference, it will be VA plus VA minus VB, which is VA plus VB. So in this case, regardless of the magnitude, it will always be positive, which means to someone sitting inside B, okay, to someone sitting inside B, it will always appear as if this vehicle is moving towards it, okay, towards it with a velocity of VA plus VB. Similarly, VBA, that is velocity of B with respect to A, with A being the reference, it will be VB, that is minus VB because it is negative, moving towards left, minus plus VA, which is minus VB minus VA, that is minus VB plus VA. So here regardless of the magnitude, to someone sitting inside vehicle A, okay, it will appear as if the vehicle B, okay, the vehicle B is moving towards left with a velocity of Vb plus Va. Okay, so this is the thing, minus Vb plus Va, it is Va plus Vb. Okay, so this is the thing. Another case is both the vehicles are moving in this direction. Here they were moving towards, here they were moving away. Let's say vehicle A is moving towards left and vehicle B is moving towards right. So in this case this will be positive, that is plus Vb, this is negative, that is minus Va. So velocity of A with respect to B with B as the reference is minus Va minus plus Vb, it will be minus Va minus Vb minus Va plus Vb. And here it is VBA with A as the reference, it will be plus Vb minus Va, which is Vb plus Va or Va plus Vb, simply we can write that. Okay, this. So here, to someone sitting inside vehicle B with B as the reference, okay, when B is the reference, it appears the relative velocity of A with respect to B, it will appear as if A is moving away towards the left with a velocity of Va plus Vb, the magnitude. And here when A is considered as the reference, to someone sitting inside the vehicle, it will appear as if this vehicle B is moving towards right, away from it, yes, away from it towards right with a velocity of Va plus Vb. So in both the cases, magnitude is the same, but sign is different. Here it is minus, here it is plus. Okay, here also the same thing. When they are moving in opposite directions, in both the cases, magnitude is the same, but sign is different. Here it is minus, here it is plus. So always remember these concepts related to relative velocity. So whenever you have any doubt with respect to it, always remember this example, this visualization thing. When you look outside, when you're driving when you are not driving but sitting in the back seat or anywhere else, when you look outside the window, it appears as if the nearby buildings or trees, they are moving towards you, visualizing as if the car is still and they are moving towards you. That will bring back all the concepts related to relative velocity. Okay, so this is a very important thing. It will be utilized in the problems, numerical problems, when we'll solve it. So it was very important concept. Okay, so I hope you liked the videos, and please subscribe my channel Engineering Tutorial for more such videos related to engineering, science and technology. Have a great day. Thank you very much.